as I was introduced, I'm Jono. I'm one of the co-founders of DroneDeploy. We've been at this for about 8 years. And I'd like to kind of kick things off with just a question. And so the question I'm putting out there is, what if every job site, and job site's pretty broad term, thinking construction, mining, agriculture, oil and gas, renewables, anywhere where work is being done outside, if we had a full 3D visual record all the way from pre-bid, before construction, through to closeout, operations and maintenance, inside, outside, having it completely accurate, where everything is measurable, and you have this digital time machine. And so that's really what we're busy creating here. So we'll see if this video plays on your side. Yeah, so we believe we're the world leader on this front. We have mapped over 220 million acres around the world. We have about 1.5 million flights a year on our platform, and that's over 1 million job sites around the world. It's been done by about 5,500 paying customers in around 200 countries. And so this is what that looks like. Each of these little blue dots around the world is someone who's gone out with a drone. They've used our applications to make that drone fly automatically and capture data, process that data, and then do some analysis with that data. And when you think about new technologies like drones, we often do get this kind of sense that it is emerging. It's still really early. It's still right at the beginning. But I really love looking at this map because it shows you that we're crossing the chasm. We're actually moving towards that early majority of people using this technology in job sites in order to track and understand what's happening in the real world. And it's not localized to any one area. We're seeing this happening globally. And so these, again, are all operations happening on our platform. And so what kinds of operations are we looking at? Easy example is something like construction. In the construction use case, throughout the entire life cycle, we're seeing our customers in pre-bid conversations. So before you even go out and try to build something, having this full 3D digital reality capture of what the world looks like allows you to have really accurate estimates of the costs of moving dirt around. Where can things fit? Do we have to change our designs? When we've got our digital twins and our BIM models, how do we have to augment those in order to fit into the real world correctly? When we actually start doing the work, the coordination between subcontractors and the general contractors, being able to communicate this data across to the owners and operators of the resulting projects, all the way through to the closeout. How do we easily test if there's heat leakage by creating thermal maps and seeing if there's any thermal leakage there? So it's providing incredible value throughout that entire construction project. And it's kind of closing that loop on that digital twin concept of we have our plans of what should be happening, and we're creating the reality of what's actually happening and allowing those comparisons and those updates to happen there. It's not just in the construction process as well. We also see this happening in agriculture. I guess I should also mention on the construction side, we've got a couple of logos here, but in the United States, we've got something called the ENR 400, which is the top 400 general contractors. And we're already seeing about 25% of them are using DroneDeploy effectively. In agriculture, we're seeing similar movements where we have these essential digital twins of fields. What seeds have we put in what densities? What nitrogen, fertilizer, pesticides are we putting in different parts of the fields? And through drones and DroneDeploy, we're able to capture that, what is the current state of the real world, and bring that into those models and update them. And the image that you're seeing here is actually a really exciting one. It's a new project that we've launched this year, it's right at the beginning of the growing season, just after you've planted your seeds. You want to know how much has actually emerged, what's actually sprouted up from the ground. And with the DroneDeploy application, you can go out there, press go, fly the drone will automatically capture this data. And using machine learning that's happening on your iOS device in the field, offline, without any internet connectivity, we can create a map in real time, so as the drone's busy flying, and we can actually count each individual seedling that has emerged from that field. And using that, we can create these population counts or stand counts and show you these are the areas that are green, that are overperforming, they're doing really well. The orange is performing as expected, and the red are areas where we're seeing a greatly reduced count in terms of the emergence of the seeds. And those could be because you've got issues with your machinery and you're not planting as much as you think you are. It could be issues with the soil, issues with the seed itself. Maybe there were heavy rains, whatever it is that kind of caused that, we're able to quantify. And this is, again, turning it from that old world where it used to be you go out there with a big hula hoop or a tape measure and you measure 1,000th of an acre or a hectare and count manually by hand, and then you just multiply by 1,000 and assume that it works that way for the rest of the field. We can now actually do that using machine learning and data science. And so we're already seeing 80% of the top seed companies are leveraging this technology. And this is permeating throughout crop insurance, the sales processes, the growers themselves. And we're seeing a huge pull in energy as well. So we work on both the traditional oil and gas as well as the renewable side. And great example here, this is one of our customers, Sunrun. They're the largest installer of residential solar in the United States. And they used to have people going out with ladders and tape measures in order to get on roofs to try and measure all the dimensions of the roofs, to understand how can we put our solar arrays on the roofs. What is the shade analysis going to be? Do we expect trees to impact? Are there any protrusions in the roof, like a chimney or an antenna or something like that we have to be aware of when we're installing this? And it used to take them hours. It was dangerous. People fall off roofs. And it was a really painful process that was also quite inaccurate, because when roofs are quite steep, you can't actually I don't know if you've ever walked on top of a roof, but it's kind of a scary thing. It's hard to get right down to the edge and get the measurements very accurate. And with the drone, they can arrive on site. They can just press go. We create this full 3D reconstruction using, again, machine learning. We can automatically extract all of the roof edges. And that gets straight into the design and planning software that they can then plan specific layouts. And through that, we have radically reduced the error rate, as well as made it much faster, cheaper, and much safer. This also works in traditional oil and gas. Again, it's one of those things, that's the way the world is. We're trying to drive the world to a much more efficient place. And using drone technology is really helping in that regard. We're able to enable many, many more inspections than would normally be done if you had to build scaffolding and put people on top of that scaffolding in order to understand what's going on. So we are really providing this horizontal solution. It is a reality capture for digital twinning in all of these different industries that we're supporting. And it's creating value throughout the entire life cycle of any of these assets, right from that kind of design phase, that conception phase, all the way through to how do we decommission, reclaim this land, take down whatever it is that we constructed. And so how we do that, we are a software company. So one thing to very much clarify, we've got all these different devices that we have data capture from on the left here. So drones, 360, normal, just like phone capture, as well as working with ground robotics, things like the Boston Dynamics Spot. We have all of these different data sources out there in the real world. And DroneDeploy is this piece of software that allows you to take all of that data, put it into our processing, where we can take those photographs and turn them into rich 3D data panoramas, videos, all in that one single location that allows you to do a whole host of different operations. And then integrations out at the tail end. So working with really top software providers out there to make sure that that data can connect into the rest of the processes that you're working with. Obviously, this is something that has been built enterprise first. So we are focused very much on data security. It's a critical thing if we're going to be taking these digital recreations of the world. Something that everyone should be thinking about is, well, how are we making sure that if we're creating this digital replicate of what's going on, that the right people have access to the right places, and something that I think everyone should be thinking about when trying to put this together. So I went through a couple of examples there of how this works, but I thought I'd share it with a few more here. So when we go back and we think about how this data is collected, a whole host of different devices can collect that data, but we're seeing that drones are one of the primary drivers there. And when we think about like what is our specialty and where do we see this world going, it's really through automation. Having robots go out and collect data, having robots do this on schedules in a fully automated manner, that's really how we can close that loop on what's actually happening versus what the design or the virtual model of that is saying should be happening. And so with the drone, all you do is you just select the area you want to make a map of, you press go, and the rest of that flight and processing is completely automated. And the result is a whole host of different data products that can then be analyzed. And those data captures can happen in a variety of different fashions, starting off with just the traditional top-down map that's for large areas that we really see in like agricultural settings, to capturing facades. So drones are now able to fly and keep distance in front of buildings. So you can do zigzag patterns going up the face of a building and get really great 3D models of the facades, as well as the indoor capture. So having robots or people walk around inside and actually capturing what's going on in that interior. And this is really the kinds of things that are being replaced with automation and data science. Is in this setting on the left here, where we're looking at this inspection process in an oil and gas setting. It used to cost in the order of $300,000 just to get the scaffolding on site, erect the scaffolding, and take the plant or whatever facility it is offline during that process. Was then an additional millions of dollars in terms of foregone processing. And so being able to keep the operation running and saving all of that cost of scaffolding and installation, as well as reducing the fall risk of putting people on high places. It's a massive improvement to use drones in order to do these kinds of digital reconstruction and inspection works. These things are dangerous, they're time consuming, and the goal that we're really trying to drive here is efficiency. The cheaper and faster it is, the more often we can do it. The more often we can do inspections, the less likely we are to run into problems, which is fantastic. So here's an example of that drone flying and capturing data. It's just zooming backwards and forwards, and you can get a video feed and see what's going on as the drone flies and captures that data. And this is what it looks like when you've got that data processed. And so this is an example here of creating a map, seeing that change over time. And then what we've done is we've pulled in the design files on top of that data. And so you can see throughout that construction process, throughout the life cycle of that project, we've got that same design file, we've got the same data, and it's showing up day after day after day. And so you have that digital time machine where you can kind of go back and forwards in time and actually compare what was the state on a certain date, what is the state today, and how does that compare to the plans that we had set out. So this is just a very simple example here, but this does also extend into kind of 3D line work and 3D design plans. The other thing that we've seen very valuable, especially in this last year, is having fully remote inspections. So enabling people to have a superpower where, again, instead of climbing on ladders or sitting on the ground with binoculars, you can do this full reality capture and then start to do inspections, flag issues, have those issues sync out into work order management systems, and then have those kind of dealt with downstream. And you can do this inspection from anywhere in the world. You don't actually have to be on site in order to do this, just using technology and these digital twins. Something else worth mentioning is just that the quality of these has really improved in the last couple of years. This technology has come in leaps and bounds. And so this is what I'd say is historically the most complicated environment in order to try and create this data, where you have lots of very thin structures, lots of pipes, lots of complicated small features. And this is using purely photography. So the drone flies around, takes photographs, and using computer vision, we do this 3D reconstruction. And the technology has really come in a long way. And it's not just the 3D data that we're creating, it's this full bevy of reality capture all in one place. And so that's elevation data, looking at takeoff and estimation, being able to import design and surface plans and seeing where there's deviations, normal photographs that could be captured by phones. The whole world is moving to this centralized data store of information, and having one place in order to access that has proved incredibly useful for our customers, at least. And going from that exterior into the interior has been a shift that we've seen in the industry in the last kind of year or two as well. So it's not just capturing the outdoor point clouds and data, but being able to go inside to have these 360-degree walkthroughs, almost like a Google Street View for the inside of your project, that you can sync, you can compare, you can create those issues, a whole host of very exciting things. So, to me, the joy of why do we come to a conference is so that we can have interaction and engagement. And sadly, I'm not with everyone in person. But I did want to kind of make some space. I kind of threw a lot of concepts out there just on how we can have these digital twins ground truthed with real world data and using drones and automation in order to drive that. And so from there, I wanted to open it up to a quick Q&A to see if anyone had any questions or wanted to spark some interesting conversation on what it is that we're doing or what we see as industry movements in terms of this drones and robotic data capture.